Welcome to Maths for You channel. Another past question on combination of differentiation and integration. Question 1, Part A, differentiate the following. Part 1, x squared divided by 2x plus 1. Let's start with that. Number 1, we can write it as y equal x squared over 2x plus 1. Prior to doing that differentiation, let me go through some fundamental. If y equal u over v, v are functions of x, dy over dx is a quotient differentiation. V times du over dx minus u times dv over dx, the whole thing divided by v squared. As the formula we're going to use. Let's look at the question as y equal x squared over 2x plus 1. Therefore, x squared is u, 2x plus 1 is v. So let's plug in. Dy over dx, v is 2x plus 1. The differentiation of x squared is 2x minus x squared, that is u. Differentiation of v is differentiation of 2x plus 1 is just 2 divided by v squared, that's 2x plus 1 squared. Let's simplify the whole thing. 2x times 2x, 4x squared. 2x times 1 is 2x minus 2x squared divided by 2x plus 1 squared. 4x squared minus 2x squared become 2x squared plus 2x divided by 2x plus 1 squared. We can take 2x as a common factor. If you do that, 2x, then inside the bracket x plus 1 divided by 2x plus 1 squared. That's the answer for the first part. The second part, y equal tan x squared minus 3x. Simply, we should know the differentiation of tan is x squared. That's the fundamental concept of trigonometric differentiation when the function is tan. So dy over dx equal tan, sec squared, x squared minus 3x. Then we'll have to differentiate one in bracket. That is x squared minus 3x. Differentiation of x squared minus 3x is 2x minus 3. If you take 2x minus 3 to the front of the function, so 2x minus 3 times x squared inside the bracket x squared minus 3. That's the part 2 differentiation. B. Let's look at the question. Use the substitution u equal root x minus 1 to integrate 1 over root x minus 1. Right, let's write that first. I equal integral 1 over root x minus 1 dx. The substitution given u equal root x minus 1. If it's so, root x equal u plus 1. We need to use it later. Du over dx, so differentiate u with respect to x, become 1 over 2 root x. We could do it x to the power half and then half times x to the power minus half, then 1 over root 2. So I just write it directly. So du over dx equal 1 over root, so 1 over 2 root x. From that, dx equal cross multiplication 2 root x times du. If we could cross multiply dx times 1 is dx and du times 2 times root x. So dx equal 2 root x du. What we have found, as I said before, root x is u plus 1. We need to change them everything into u. So root x is u plus 1. 2 times u plus 1 du. So dx in terms of du and u. Let's go back to that, the integration. I equal root x minus 1 is u, the substitution. So 1 over u times that for dx, we can substitute 2 times u plus 1 du. So that's what it is. If we simplify, 2 out, 2 as common out, nominator u plus 1 over u, then further simplification, 2 integral 1 plus 1 over u. So 2 integral of 1 is u plus 1 over u ln u, log e to the base ln u, plus c is the integral constants. C is a constant. But just to give you a bit more detail of this ln u, if the denominator, nominator is the differentiation of denominator, the integral of that function is ln u. So for example, on this side, as integral of 1 over x dx, that is ln x. So the nominator is the differentiation of denominator. So x is a denominator. Differentiation of x is 1. So 1 over x is ln x. That is exactly what here. So 2u ln u plus c. C is the constant. So let's go back and substitute back to x. I equal 2 times for u root x minus 1 plus 2 ln for u ln root x minus 1 plus c. That's the final answer. Let's go to part C. That is integrate x minus 2 divided by 2x squared minus 8x minus 1. So integration I equal integral x minus 2 over 2x squared minus 8x minus 1. When you normally have a question, sometimes it's you look at the previous part, there's a hint in it. So first part is ln, the log function involved. So here we have a linear function on the top, a quadratic function on the bottom, or in other words, linear function denominator, the quadratic function numerator. So when you actually the quadratic differentiate, it will be linear. So there is a connection there. So we'll try and work out what that connection is. So if you look at it, the differentiation of the denominator, 2x squared minus 8x minus 1, 2x squared will be 4x and minus 8. But there, if you look at the numerator, we have a pattern there. So we can multiply by 4, the top numerator is 4 times x minus 2. If you multiply 4 by 4, then of course we have to divide by 4. So in total, that's 1 over 4 integral 4 times x minus 2 divided by 2x squared minus 8x minus 1 dx. Simplify to just to make it correct. 1 over 4 integral. If you expand the bracket, 4x minus 8. So you can see that the differentiation of the denominator, which is 4x minus 8, and we have 4x minus 8 in the numerator. So that means direct log function. So integral of that function will be ln. So 1 over 4 ln, the denominator, of course, the 2x squared minus 8x minus 1 plus c is a constant. So that is the C part. So just a little hint or advice is normally that the later part may have some connection with the earlier part. So here, if you look at it, and then we have ln, that's this part B. We have in the answer ln. So just the second one is some kind of information. So this is can be part of ln ln. So that if you look at the linear function on the numerator and the quadratic function on the denominator, so so if you differentiate the quadratic, it will be linear. So just we can manage to get that differentiation on the numerator side. So that is exactly what we did because of the clue from the part B. Thank you.